I'm Carrie Enos. I'm the president of the Pulp and Paper Foundation at the University of Maine. The best part of my job is interacting with the students. So Jen Ireland, who's our program director, and I are both alums of the program. So we get to mentor them. We kind of have walked in their shoes and we kind of know what they need to be successful in industry. And we could also help them navigate just being a college student and all that goes with becoming an adult, right, for these 4 years that they're here with us. So that's my favorite part, for sure.
My name's Daigle. I'm a reliability engineer here at Croix Tissue. I'm a recent graduate of the University of Maine, and I graduated with a bachelor's degree in mechanical engineering. During my time at UMaine, I was a recipient of the Pulp and Paper Foundation Scholarship, and I attended a seminar in the fall of my senior year. Matt Cowen gave a presentation that introduced me to KCF as a company.
The seminar that Matt conducted was about vibration analysis, remote monitoring, and the things that the industry is doing to kind of move into the next century in terms of being able to predict what might go on in their machines and prevent failures before they happen.
My name's Matt Cowen. I'm the National Sales Manager for our Building and Consumer Products team at KCF Technologies. As a part of my role with KCF, I'm actively trying to engage with universities to educate students about machine health platforms, essentially prepping an entire new generation of engineers that need to leverage big data to take the right action at the right time.
My name's Jesse Stevens. I'm the operations manager here at Croix Tissue. I'm a chemical engineer from the University of Maine. The University of Maine's only an hour and a half away from here, so a large percentage of the engineers and staff we have on site come through the University of Maine system. It's a very good school. You know, the engineering program there is great. One of the things that we find here that makes the University of Maine so critical to our site is it lets those students come back and work within their local communities.
I've had experience with vibration analysis, but all of it was manual data collection. So someone had to manually go around with a device and physically be at each bearing every time they wanted to take data.
There's an incredible skills gap that is developing, and we need to have young engineers that can use data in a different way to leverage bigger and better things. Ideally, you've got people that have been working in this space for 30, 40 years, and that's a lot of tribal knowledge. So with this type of machine health data that we're providing for these young engineers, it's their way of potentially filling those shoes that have walked out the doors.
Our goal is to make these students a whole person and a whole engineer. We are trying to do our best to prepare them to be able to hit the ground running. It's not about coming in and just changing everything. It's understanding what really are the problems, what have we already done to try to solve it, and then how we might have tools that are available that can help them resolve the problem for good.
A few months after the presentation, I was graduating from UMaine, and I started at Croix Tissue, and I was lucky enough to have a supervisor like Moran Hamilton, who was actively implementing a pilot program with KCF Technologies. The pilot program consisted of 100 wireless sensors being deployed throughout the mill, and they were mounted on some of our most critical assets. And these are assets that, if they broke down, that would be causing us machine downtime and financial losses for the company.
I was really excited to hear that he was going to be essentially running lead on this 90-day pilot that we ran here at Croix Tissue.
The immediate long-term benefit that comes to mind is just overall better reliability and maintenance of our equipment. If we're taking readings on a monthly basis, something could go wrong with that equipment a couple days after that first reading, and we might not know it until the next month when we take that reading. So if we don't have the opportunity to catch those small defects, you know, right at the point when they begin to happen and these sensors pick them up, if we have to wait that month, that type of damage can cascade through gearboxes, bearings, and it can continue to cascade and do larger process effects that just compound the losses.
One of the best catches we had during the pilot program was with one of our vacuum pump gearboxes that we saw an increase in vibration on, which was indicating that it was nearing failure. And once it reached a certain threshold, we could do a controlled shutdown of the machine and replace the gearbox. Because of that predictive maintenance catch, we were able to save significant downtime on the machine, which in turn saved the company a significant amount of money.
Not only did Alex make this pilot a success, he has played a critical role in convincing the leadership of this mill to expand into other areas.
It was clear early on in the program that predictive maintenance wasn't going to be the only major benefit with these sensors. The vibration data that we were collecting was also valuable in influencing operational and process decisions. If we're running into a critical piece of equipment that could be failing, that then becomes a priority. KCF vibration data is another tool in our toolbox which allows us to be proactive rather than reactive in our maintenance practices.
A lot of the mills in Maine were built well over 100 years ago. So they've got established systems and processes and equipment in place, and having these new students come through the University of Maine already exposed to the industry of things and tools such as these KCF sensors really helps jumpstart these older sites to really continue to push into the future and into the next state of operation. And having this partnership with the university is very advantageous to making that happen.
Investing in our program is one of the ways you end up with someone like Matt Cowen coming in to give a presentation to students, having a student, Alex Daigle, who's sitting in that audience, then goes to work for your company, Croix Tissue, and brings this technology to fruition in less than a year after graduation and really makes a huge impact on your business. The people at Croix are seeing a huge benefit from our alumni and from the technology that KCF is providing, and they have nothing but great things to say about the impact that technology has had.